We thought it would make a smart move to make the deposit, partner with Tesla. So we'd put a deposit down several years ago for 100 units when they first announced.
With an initial quantity of 100 Tesla semi-trucks exclusively reserved for PepsiCo's truck fleet, this promises to make a significant impact on the future of the transportation industry and the global demand from individual customers. It's known that 1% of the current diesel pickup truck fleet on the roads is causing 20% of the environmental pollution. However, alongside this, there are conflicting opinions about the potential increase in pollution when electrical energy sources are also included in this list. Ahead of the anticipated production boom of Tesla Semi in Nevada in 2024, some insiders have disclosed issues that Tesla seems to have not previously announced, prompting the needs for solutions. What are those problems? Let's find out in today's episode of Tesla Car World. Welcome back to our channel. Before we begin, please show your support by subscribing if you haven't already, and ringing that bell so you won't miss out on any of our interesting videos in the future. Now, let's get started with today's content. What's going on with the Tesla Semi's real-life range? The Tesla Semi boasts a claimed operating range of 500 miles and can compete with some of the longest-range electric vehicles. However, not all electric trucks offer such an exceptional operating range. The Freightliner e-Cascadia is officially rated to travel up to 230 miles on a full charge, which is less than half the operating range of the Tesla truck. Nevertheless, both Tesla and Freightliner fall short when compared to the operating range of a diesel-powered long-haul truck. The average fuel efficiency of a truck is about 6.5 miles per gallon. Assuming you're driving a diesel truck with two tanks totaling 120 gallons, you would get a robust driving range of approximately 1,560 miles, equivalent to about 28 hours of driving. It's true that truck drivers wouldn't drive this far without stopping to rest. A U.S. regulations limit driving to a maximum of 11 hours a day with at least a 30-minute break within an 8-hour span. Therefore, at least 3 days of driving and at least 3 30-minute breaks are required to comply with the law, along with scheduled stops for rest and cargo handling. However, the fact that they don't need to stop for fuel frequently is a significant advantage in the transportation business, where time is money. The added peace of mind about the substantial range is excellent to have. On the positive side, the limited operating range of electric trucks could be an advantage for driver safety. It restricts the number of miles a driver can cover on a single tank, essentially requiring them to stop and rest. However, these rest periods coincide with charging the electric truck. So what one encounters is not an issue of range, but rather a matter of planning and organization. A 400-mile range for an electric vehicle with a 30-minute charging time still equates to approximately 8 hours of driving, making it well-suited to the Tesla Semi model. We don't know the fast charging cost at Megacharger, but it can be charged slowly at any home or business facility paying standard electricity rates. If we assume it's 23 cents per kilowatt hour based on the average electricity rate in the US, and a 900 kilowatt hour battery for the 500-mile, it would cost $207. A new average diesel truck in the US covers 6.5 miles per gallon, so traveling 500 miles at $3.90 a gallon would cost $300. Therefore, a long-haul diesel truck costs 60 cents per mile to operate, while the Tesla Semi costs 23 cents per mile. These electric truck models are helping businesses save a significant amount of money. For a diesel truck with two 150-gallon fuel tanks averaging around 6.5 miles per gallon at highway speeds of 65 to 75 miles per hour, frequent delivery trips often cover distances ranging from 1,000 to 1,400 miles between refueling stops. Refueling typically takes 15 minutes or less. That means that in a demanding week of driving, a driver may spend a total of 45 minutes refueling to cover 4,000 miles. In contrast, the Tesla Semi can travel 500 miles on a full charge. After that, it requires a minimum of 30 minutes on the most powerful charging stations currently available to recharge up to 80%, enabling an additional 400 miles of range. Additionally, there's the issue of driving time. In many states, truck drivers can legally and comfortably drive up to 700 miles a day. Most long-haul truckers may not consider adopting electric vehicles until the operating range is assured to be over 800 miles when fully loaded, at highway speeds averaging 65 to 75 miles per hour across all terrains and under any temperature conditions. In this way, one could drive 700 miles a day and charge the vehicle during a 10-hour rest period. So, to cover 4,000 miles per week, you're looking at spending over 300 minutes sitting at charging stations, which is at least 5 hours where the driver is not getting paid, compared to 45 minutes for a diesel truck. Furthermore, driving an electric truck through peaceful roads in ideal climate conditions sounds great. But what about driving in the cold winter? Electric vehicles seem to face the challenge of range loss in winter due to the fact that lithium-ion batteries don't perform well in cold temperatures and need to be kept at ideal temperatures. Most electric vehicles experience reduced range when the temperature drops to 40 degrees Fahrenheit or colder. To address concerns about cold weather performance, Tesla has integrated a seat heating system into the Tesla Semi, along with a low-voltage 48-volt power system expected to be equipped in 2024. This not only enhances the driving experience in harsh weather conditions, but also ensures that the entire electrical system will continue to operate smoothly even when the main battery is running low on energy. This low-voltage power system not only positively impacts the vehicle's performance, but also addresses the need for warmth in extremely cold conditions. When the vehicle is parked in cold regions, this system will proactively heat the entire electrical system, helping to maintain stable and efficient operation of the vehicle. When temperatures significantly drop, the chemical reactions that the battery relies on to generate energy slow down, leading to a decrease in energy output. Consumer reports have noted that cold weather can reduce the range of electric vehicles by up to 25% when driving at speeds of 70 miles per hour. Regular driving in frigid conditions can even result in a 50% reduction in the vehicle's operating range compared to the manufacturer's stated range. Many believe that similar cold weather limitations apply to this bullet electric trucks and use this as an argument against them. However, we don't think this will be the case when looking at the numbers. Firstly, while there are multiple factors, the primary reason for decreased range in cold weather is the additional electrical consumption required for cabin heating. Consider an uncomfortable but common scenario. Imagine a temperature of minus 10 degrees Fahrenheit with low visibility due to snow. You can only drive at 50 miles an hour. Most electric vehicles operate efficiently at this speed and can achieve around 5 miles per kilowatt hour. This implies that the vehicle consumes 7.5 kilowatts at minus 10 degrees Fahrenheit. Even cars with resistive heaters would have to operate in electric resistance mode, consuming maximum power. Meanwhile, the Tesla Semi is reported to have a consumption rate of 1.7 kilowatt hours per mile and is said to be equipped with a 900 kilowatt hour battery. The electric vehicle EV drivetrain has an efficiency of around 90%. Discharging the battery generates heat, as does the motor. This means that approximately 8.5 to 11.1 kilowatts of thermal output will be produced. This is already much more favorable compared to the heating requirements for a passenger car. Moreover, the form factor is also crucial. A 900 kilowatt hour battery has a large physical size. To enhance cooling efficiency, especially during fast charging, and reduce the weight of the casing, pipes, and wiring systems, the battery needs to have the lowest possible surface-to-volume ratio. It's no surprise that the Tesla Semi packs its batteries more like a cubic block than the typical skateboard configuration in consumer electric vehicles. This means that more thermal energy can be recovered rather than being lost to the environment. The cabin of the semi-truck is not significantly larger in terms of overall volume compared to a large consumer electric vehicle, and has fewer windows since it is ultimately designed for a maximum of 2 drivers. Therefore, I doubt that climate control will require much stricter management. Even if heating is needed twice as much in a vehicle with more windows, the thermal output alone is sufficient to address this issue. Even if the thermal output cannot be used for cabin heating, which is unlikely as Tesla leverages this for vehicles equipped with a heat pump, the loss in operating range will be less than 10%. How do you think Tesla will solve range problems? Leave your thoughts below in the comments. We'd love to discover what you think. Why doesn't the Tesla Semi have a bed behind the driver's seat? When transporting goods across country, the truck's cab serves as the driver's home away from home. According to Freightliner, one of the largest long-haul truck manufacturers, a driver with an average of 45 to 65 may spend hundreds of hours in the truck each week. Therefore, the interior of the truck must meet the needs of the driver, keeping them safe, alert, well-rested, and ready for the next day of driving. Sleeper cabins, as the name suggests, allow drivers to sleep in the truck without worrying about accommodation during the journey. Modern sleeper cabins from truck manufacturers like Freightliner, Peterbilt, and Kenworth come equipped with amenities such as refrigerators, microwaves, TVs, and cabinets to ensure the driver feels as comfortable as possible. However, with the new Tesla Semi delivered in late 2022, it has garnered attention with its captain's chair positioned in the center and a dual display screen for the driver. This is not the typical layout for a conventional truck cabin, leading many to believe it is a product from the future. In terms of amenities for the driver, it features a wireless charging pad, coat hooks, and a rear passenger seat. However, it lacks any sleeping arrangements for the driver. This is a completely day cab configuration, meaning it is not suitable for extended multi-day trips. Tesla has removed many standard features in the new long-haul taxi version. The most significant among them is the rest area, where drivers might catch some sleep along their route. Furthermore, having this dedicated space becomes more crucial when there is an additional co-driver preparing to take over whenever needed. This gives them a place to rest or at least relax a bit to recharge. Tesla has revealed that their designers are considering various sleeping arrangements for the future, and it will extend the length of the cabin rather than the overall length of the truck. It's impressive how Tesla Semi is making an impact in various ways. It can move quickly, efficiently, and carry enough weight to keep up with diesel-powered vehicles. But some opinions suggest it may not be the perfect truck for every transportation scenario. With a relatively simple interior and a maximum range of 500 miles, a Tesla Semi is suitable for regional transport rather than cross-country journeys. Currently, those tasks will still be the territory of diesel-powered trucks. This brings us to the next big question. What's going on with Tesla's Semi's charge network? Typically, Tesla car buyers may go home every night and charge their cars there. However, becoming a long-haul truck driver is not as predictable. Truck drivers need the best diesel stops with parking lots across the country to refuel. To address the discrepancy between the availability of diesel fuel and the number of charging stations, a joint venture in Europe with Daimler, Volvo, and others is investing an equivalent of $534 million to build 1,700 charging points for electric trucks. Tesla Semi is not currently performing cross-country runs. However, with a 500-mile range per charge, a network of interstate charging stations will be necessary for the truck to compete meaningfully with diesel-powered vehicles. Moreover, Tesla Semi seems incompatible with other electric charging points, and at the Modesto facility, PepsiCo stated that there were only 4 charging units for 15 trucks. This could diminish the significant cost-saving benefit of Tesla Semi in fuel efficiency. Tesla Semi's website advertises that electric charging will be about 2.5 times cheaper per mile than fueling with diesel engines. Notably, this is based on the cost of diesel fuel in California, often much higher than in the rest of the United States, and in 2022, a record year for fuel costs. The lack of a charging network is another significant obstacle that Tesla Semi must address if it intends to challenge current manufacturers. However, apart from road warriors, a robust charging network is not a major concern for its core retail audience. Tesla is known for its high-speed supercharger network, providing fuel for millions of electric vehicles worldwide every day. Following the success of this network, the brand is currently doing something similar for its Class 8 road transport product, the Tesla Semi with megachargers. High-speed charging units have a rated power 3 times that of Tesla's Supercharger V3, which is limited to 250 kilowatts. It can charge at a massive power of 750 kilowatts with these chargers. In a proposal with the U.S. Department of Transportation, Tesla plans to develop a total of 9 charging locations along the 1,242-mile long-haul route from California to Texas. Each planned location is expected to have a total of 12 high-speed charging units for Tesla Semi. The lack of charging network is another significant obstacle that Tesla must address if it intends to challenge current manufacturers. However, apart from road warriors, a robust charging network is not a major concern for its core retail audience. How do you think Tesla will solve these problems? And when can Tesla achieve its goal of mass production of the Semi? We appreciate your contributions and hope you'll have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thanks so much for watching, and we'll see you soon. Until then, stay safe and have fun.